going to do one more problem together that involves a system of three equations and three variables. And I like this problem a lot. I think this is a fun, it's kind of abstract, but a neat application of solving a system. We all know that if we're given 2 points in the xy plane, there is exactly one line passing through those 2 points. We can find an equation of that line. That's not what we're going to do here. We already know how to do that. Here's what we're going to do. Now, suppose that we are given 3 points in the xy plane, 3 different points. We can actually try to find a parabola, so a quadratic function of the form y equals ax squared plus bx plus c that passes through each of the 3 points. And that's the exercise we're going to go through here. We're going to find an equation of the parabola that passes through the point 1, 0, the point negative 2, 12, and the point 3, 2. And I just, ahead of time here, I tried to set up a sheet of graph paper. I guess I made this kind of huge to fit on the screen right now, but here's one of the points, here's the second point, third point's way up here. And so we're trying to find a parabola, an equation of a parabola, that will hit each one of those 3 points exactly. Okay. So what does this have to do with a system of linear equations? Because a parabola seems like a very kind of quadratic thing. Well, let's start going with this. So I'm going to take, I'm going to suppose our parabola is given by y equals ax squared plus bx plus c. We need to find values for the constants a, b, and c. And then we'll have an actual equation, an equation of a very specific parabola. So each one of my points lie on that parabola, so I'm going to take the first point, 1, 0, take that equation, y equals ax squared plus bx plus c. Well, 1, 0's got to satisfy that equation. I can plug in 1 for x, 0 for y. So I get 0 equals a times 1 squared plus b times 1 plus c. So remember, the x coordinate is 1, the y coordinate is 0, so 0 equals, this just becomes a plus b plus c. Okay. I'm going to do the same thing with negative 2, 12. I'm going to plug into that same equation, y equals ax squared plus bx plus c. So that y coordinate 12 has to equal a times negative 2 squared plus b times negative 2 plus c. So 12 would equal, now negative 2 squared is positive 4, so 12 equals 4a minus 2b plus c. And my third point was 3, 2. So I'm going to plug that into y equals ax squared plus bx plus c. And so the y coordinate 2 should equal a times 3 squared plus b times 3 plus c, or 2 should equal 9a plus 3b plus c. So I have these 3 equations now. I'm going to call this my equation 1 here, equation 2 here, equation 3 is here. Let me just recopy them. 0 equals a plus b plus c. 12 equals 4a minus 2b plus c. 2 equals 9a plus 3b plus c. I have to solve the system for A, B, and C. So A, B, and C are like my variables at this point. They're like the x, y, and z. I'm just not using x, y, and z. I have three linear equations in A, B, and C, and I'm going to apply the process that we talked about in the previous video to solve this system. So I'm going to isolate one of the variables in one of the equations. So I'm actually going to, so I choose, there's definitely more than one way to do this, but I choose to isolate the A in equation 1. And so if I take that equation 1, let's put a 1 here, 0 equals A plus B plus C. If I isolate the A, I'm going to take the B and C to the other side, so I get minus B minus C equals A. Or I can just say A equals minus B minus C. So I have A isolated in the first equation. Then I can substitute into equations 2 and 3, into the second and third equation. And I'm going to do that on another sheet of paper here. So if I take equation 2, which is right up above there, equation 2 is 12 equals 4A minus 2B plus C. I'm going to replace A with minus B minus C. 12 equals 4 times, so here's my substitution. Minus B minus C, in parentheses, minus 2B plus C. So when I make that substitution now, I have an equation with just two variables, and I'm going to clean up. I got to distribute the 4, so 12 equals negative 4b minus 4c minus 2b plus c, where 12 equals minus 6b minus 3c. Okay, got it for equation 2. Now take equation 3, which was 2 equals 9a plus 3b plus c. And I'm going to substitute a again, my same choice of a, my minus b minus c. So 2 equals 9 times minus b minus c plus 3b plus c. And so 2 is equal to negative 9b minus 9c plus 3b plus c. 2 is equal to, looks like I got negative 6b minus 8c. So after doing those substitutions, I have a new form of the equations 2 and 3. What I'm going to do is bring those two together. And solve that system of two equations. So solve for B and C in these two equations in two variables now. Now there's, again, a lot of ways you can proceed here. Let's just say this is what happened in my equation 2, what happened in my equation 3. There's no official rule on how to proceed here. I could take equation 2 and divide by 3 to isolate C. Divide by 3, I got 12 equals negative 6b minus 3c. And if I divide, I get 4 equals negative 2b minus c. I'm going to add c to the left, subtract b, I think I get c is minus 2b minus 4. And now I'm going to substitute into equation 3. Take my 2 equals negative 6b minus 8c from just up above. And so 2 is equal to negative 6b minus 8 times negative 2b minus 4. In parentheses, 2 equals negative 6b. Now I got to distribute. And I'm going to get plus signs here because I'll get plus 16b plus 32. And I should be able to solve for b now. I'll have negative 30 equals 10b. Divide both sides by 10, negative 3 equals b. So I got a value for b. And what I'm going to do is on this sheet, I'm going to come back up to the right-hand side. I got negative 3 is equal to b. Now I got to find my a and c values. Anywhere along the line, I can use any equation that just has a b and a c. I'm actually going to choose the equation I got where c was isolated, right? So c equals negative 2b minus 4. C equals negative 2b minus 4. So c equals negative 2 times negative 3 minus 4. Plugging in the value for b, c is equal to 6 minus 4. C equals 2. So now I got a c value. And I got to find a. And I'm going to go back to, I think it was back actually on the first page. Remember, a was minus b minus c. So I can plug in both the b and the c value here. So I get minus a minus 3. Minus c is 2. So a is going to be 3 minus 2. A is equal to 1. So I got an a, b, and a c. Now what we can do is we can go back to our equation. The parabola y equals ax squared plus bx plus c. I'm going to replace a with 1. Y equals 1x squared plus b is minus 3 plus minus 3x plus c is 2. So y equals x squared minus 3x plus 2 is a parabola that contains, or that has each of those 3 given points from the beginning of the problem, right? We wanted 1, 0, negative 2, 12, and 3, 2. And so we're done. But I just want to go to this graph and think about what the graph of y equals x squared minus 3x plus 2 would look like. We can find the vertex using the negative b over 2a formula. Negative 3 over 2 times a is going to be 3 halves, or 1.5. If I plug in 1.5 squared minus 3 times 1.5 plus 2, so I got 2.25 minus 3 times 1.5 is going to be minus 4.5 plus 2. Actually turns out to be negative 0.25. So the vertex is 1.5 negative 0.25. So 1.5 is right here on my graph. If this is negative 1, negative 2, so 0.25 is very, very small. Okay. Now I'm going to plot a couple other points here. My y-intercept is 2. We know the point 1, 0 satisfies it. You can check because we found a parabola that would pass through. Here's one of our points. When x is 2, I get 4 minus 6 is negative 2 plus 2 is 0. The point 2, 0 is on our parabola. I know it goes around like so. And at negative 1, I'm going to do that in my head. I get 1 plus 3 plus 2 is, at negative 1, I think I get 6. And at 4, I get 16 minus 12 is 4 plus 2 is also 6. Just extending this a little further. Okay, maybe I got enough. And here, I just wanted you to see this picture of, that's the parabola we found in this problem. You didn't, the graph is not part of the exercise, but here was our point negative 2, 12. Here is the point 1, 0. Here is the point 3, 2. Those were those 3 given points. We actually found a parabola, the equation of a parabola, that passes through those points by solving this system. I don't think I can fit it all on one screen. Here was the start. And then what I'm going to do is I'll put the second page here and pull the camera back a bit to get the second page. And there was the end of our calculation. So, cool problem. And here's a graph.